Okay, so this is the setup for the PS60 negative 1100 volt for 1 millisecond test. So here we have three power supplies that produce 300, just over 360 volts each, isolated DC output, and those three units are stacked in series to give 1100 volts. Their outputs connect to give 1100 volts across the capacitor bank here. Those relays are connected so that when the energy pulse from the capacitors is discharged into the DC to DC converter, which is here, the power source, the three power supplies that are charging the capacitors, can be disconnected from each other, so that as the energy is taken from the capacitor bank, the power supplies don't keep pumping energy into the capacitors, which would prolong the duration of the test. So the capacitor value is set to give the 1 or 2 milliseconds time period for the minus 1100 volts. So here is the DC to DC converter. You can see from the LED that the output is on, it's giving 12 volts. There is the battery that's powering the unit, and what we have here is a transformer with a high inductance. It's an iron core inductor, and basically this will withstand sufficient volt seconds to allow the pulse, the negative energy pulse, to be applied to the input of the DC to DC converter without that energy pulse being clamped by the battery, or without it in fact damaging the battery. So when we actually measure the battery, there is no significant negative dip at all. The negative voltage appears across the inductor. The actual minus 1100 volt spike is applied direct to the input of the DC to DC converter, and this enables the DC to DC to continue running at all times whilst the negative energy is dumped into the unit. This is a good test because the power supply's own internal standby disable circuits remain connected, and this makes sure that the negative 1100 volt pulse is applied to all parts of the circuit where it can get. And so here we have the plate where the 1100 volts will appear, and what we do is make a momentary connection with a probe, and that momentary connection with a probe will apply the voltage to the input of the unit. As I said, when we actually make this connection, we actually switch the relays off so the power source is disconnected, and we do that by turning off this power supply. This power supply is actually an enable for these three power sources. When the enable is switched off, these units switch off. So to start the process, what we'll do is switch off the enable power supply, and that means that we're now ready to run a discharge from the capacitors, and here we go. And once more, and what we'll do now is we'll just look at the storage scope, and what you can see here is that this is 1 millisecond per division, so we can see around 4 milliseconds where the voltage is at minus 1100, and then the voltage pulse recovers. The amplitude is minus 200 volts per division, so here is 0 volts, here is minus 1100 volts, here is around 4 milliseconds which is the time it takes to discharge the capacitors. And here you can see the test being repeated around once every 5 seconds, thereabouts, which is the requirement in the standards. Just to explain that, as we said, the 3 big power supplies here are charging the bank of capacitors, then the power supplies are switched off and the relay is open circuited, and then only the energy in the 3 capacitors here is dumped into the DC to DC. As we can see during the test, although 1100 volts negative is applied to the unit, the LED indicating the DC output voltage at 12 volts does not flicker. There's no interruption to the unit's performance. And so in actual fact we can repeat this test on a continuous basis with no disruption to the DC out from the unit and no damage to the unit. And one more time. And there concludes a summary of the negative 1100 volt testing on the PS60 DC to DC power supply. Thank you for watching.